Today's practical is on chromatography, which is one of the required practicals for chemistry. Chromatography is a separation technique which can be used to separate out and identify unknown substances. It has two phases, a stationary phase and a mobile phase. Now this is a physical process, meaning that no chemical reactions occur and no new products are formed. Now, the separation of the substances in a mixture depend upon their solubility in the mobile phase and their retention in the stationary phase. Now, in this practical, we will be investigating the separation of food colorings, and we will be using paper chromatography to do this. So, the independent variable in this practical is the separation of the food colours. The dependent variable is the distance travelled by the colours along the chromatography paper, and the control variable would be the solvent used, the food colours, and the type of chromatography paper used. So, we can start off by doing a risk assessment. Although this is a low risk practical, we still need to be careful because we're using glass equipment and we need to avoid breakages. So, we will start off by preparing our stationary phase. This is the chromatography paper, that is the stationary phase. Now, this paper has been cut to size to fit in nicely into this beaker. So firstly, we need to draw in a baseline 2 centimeters up from the bottom of the paper. And we need to use a pencil to draw this line. And the reason for that is, if we were to use a pen, when putting the chromatography paper into the water, the ink from the pen would run off the paper, mix in with the solvent, and then travel up the chromatography paper, mixing in with the food colours, giving us invalid results. So now the baseline has been drawn. I need to now mark in 4 crosses as to where my food colours will go. Now the crosses should be separated out, and make sure that the colours are not put on the edges of the chromatography paper, otherwise you will not get a proper separation. So I have marked in 4 crosses. Now the colours that I am using are blue, yellow, red, and an unknown colour. I have labelled the blue A, the yellow B, the red C, and the unknown colour is labelled U. Now colours A, B and C are pure substances, and the unknown colour U is a mixture of substances. I shall just label the crosses so I know which colour will go where. And I shall start off by putting colour A onto the cross that has been marked A. And I'm using a capillary tube to do this because the capillary tube will give me just the right amount to place on the cross. Sometimes you need to do this a few times to get a reasonable size spot. It's better that the spot is no more than 2 to 3 millimeters in diameter. Next, colour B. And now C. And finally, colour U. We need to wait just a little while for the colours to dry before we introduce the stationary phase into the mobile phase. I need to take a wooden splint to the top of the chromatography paper with some sellotape. Okay, so our stationary phase is now ready. Now in this beaker I have water, preferably distilled water, and the depth of the water is just slightly 1 centimeter, and it's 1 centimeter because I do not want the water level to be above the baseline. And the reason for this is that if the water is above the baseline, the colours will just wash off the paper and into the solvent, and we will not get any separation. Now I can put the chromatography paper into the water and wait for the colours to travel up the chromatography paper at least 3/4 up. The chromatography paper should not touch the sides of the beaker, and the bottom of the paper should just dip into the water. The wooden splint is there to hold the chromatography paper in position. This usually takes about half an hour. You can see the colours moving up the chromatography paper as the water is rising up. We can now remove the chromatogram from the water, and immediately we need to draw in a pencil line close to the wet edge on the chromatography paper. This is to mark how far the solvent has travelled, and this line is called the solvent front line. We can now hang this up to allow it to dry completely. This chromatogram has completely dried, and as you can see, the colours have separated out. Colour A is showing a single colour and has separated out towards the top of the chromatography paper. Colour B is also showing a single colour and has separated out towards the bottom of the paper. The same for colour C, it is showing a single colour. And if you have a look at the colour U, which was our unknown colour, it has separated out into two colours, a blue and a yellow. And this will indicate that our colour U was a green colour. Now, from the chromatogram, we should be able to work out RF values. RF stands for retention factor, but we cannot work it out from this chromatogram because we cannot work out the separations very well. So we will use a sample chromatogram instead. Now in the exams, the chromatograms will look a lot more like this one. Now the retention factor is calculated by dividing the distance travelled by the spot by the distance travelled by the solvent. Now on this chromatogram I have drawn in the solvent front line. So to start off with, we will be working out the RF value for our colour A. So first of all, I need to measure the distance travelled by the solvent, and that is coming to 105 millimeters. And now to measure the distance travelled by the colour, and that is about 85 millimeters. Now I'm measuring the spot up to the midpoint, because sometimes we don't know how far up or down the colour has separated. So the RF value for our colour A would be 85 divided by 105, which equals 0.8. We can then repeat the calculation with our colours B and C. Now, the problem with this practical is that if we leave the chromatogram in the water for too long, the colours will separate out far up on the chromatography paper and we will not be able to view any separation.